All right, see if you can figure out the formal charge of each of the atoms in this molecule, and then see if you can get what the actual overall charge of the molecule itself is. So press pause, work on it yourself, and then when you're ready, press play. All right, so hopefully you've worked on it by yourself, and now we'll go through each of the charges on this molecule. So let's start by looking at this oxygen on the far left, and as always, we're going to ask two questions. We need to know the number of bonding electrons and the number of non-bonding electrons. Okay, so how many bonding electrons does this oxygen have? Well, it's bonded to this oxygen. So that means that there's a total of 2 bonding electrons, okay? And how many non-bonding electrons do we have? Well, we've got 2, 4, 6. So 3 lone pairs, so a total of 6 non-bonding electrons. So that actually gives us a total of 6 non-bonding electrons. Let's then apply this to our formal charge formula. And we're going to start with, we got to know the number of valence electrons in a free neutral atom, in this case of oxygen. And so there are 6 valence electrons in a free neutral atom of oxygen. So 6 minus 1/2 times the number of bonding electrons, so that's 1/2 times 2, so that's 1. Again, you get the same answer, actually, if you just plunk down the number of bonds in this category. Gives you the same thing, that's fine. The number of non-bonding electrons is 6, so 6 minus 1 minus 6, that's the same as 6 minus 7, so give us a number of minus 1 here. Or a negative, just draw a negative charge. Okay, good, so that's minus 1. Okay, let's look at the middle oxygen. So middle oxygen, it's got so 2 electrons per bond, so a total of 6 bonding electrons. And non-bonding electrons, it's only got 1 lone pair, so total of 2. And in a formula down the bottom, just again, plug and chug here. 6 is the number of valence electrons in a free neutral atom of oxygen, so this remains the same. 1/2 times 6 gives us 3. Again, get the same answer if you just count the number of bonds. And from this, we're going to subtract the number of non-bonding electrons, which is 2. So 6 minus 3 minus 2, that gives us plus 1. So plus 1, but like I said, normally we'll just draw a plus. Okay, and then the last example here, the last oxygen. So we've got bonding electrons. Well, there's a total of 4, right? There's 2 bonds. Each bond has 2 electrons. And the number of non-bonding electrons, we've got 1, 2, 3, 4. So 4 non-bonding electrons. And if we just look through our formula here, keeping this the same, it's still 6. 6 minus 1/2 times the number of bonding electrons. So 6 minus 1/2 times 4 is 2, minus the number of non-bonding electrons, which is 4. So 6 minus 2 minus 4, that gives us 0, right? So this has a charge of 0. We often won't even bother writing that in. So overall, the charge is minus 1 plus 1 plus 0. The total for that is equal to 0. So it's actually, overall, it's a neutral molecule. It bears no net charge, but there are charges present on this molecule. And this molecule hopefully should be familiar to you. It's called ozone. You've certainly heard of it if you haven't seen its structure before. So ozone, as it's bad for us at the surface of the Earth in traffic pollution, and it's good for life up in the upper reaches of the atmosphere, where it protects us from damaging ultraviolet radiation. So that's ozone. Those are the formal charges of ozone. Overall, it's, like I said, a neutral molecule.